Ever get that feeling like you're looking at something in nature? And it's just mind-blowingly complex. Take a peacock feather. Those colors are unreal. But you know it's even more wild? It's not pigments creating that dazzling display. It's all about how light plays with the feather's structure. Pure elegance.
Yeah.
Pure genius. And that's what we're diving into today, how nature's ingenuity sparks our own inventive spirit. We've got a fascinating lecture here on innovations in chemical technologies. And trust me, you're going to want to take notes on this one. So let's start with the foundation of it all, invention. We're talking about those rare, earth-shattering moments when something entirely new comes into being.
And it's not as simple as just having a light bulb moment. You know, that whole patent process,
Yeah.
the one that officially designates something as truly unique, it's rigorous. In fact, a lot of patents are granted for innovations that improve upon earlier inventions. Impressive feats in their own right.
Right. Yeah. But like building a skyscraper, you need that solid foundation before you can even think about reaching for the clouds. The lecture points to some incredible examples of these first-time inventions. Gunpowder, nuclear fission, Jock in vitro fertilization. Talk about changing the course of history. And then there are the inventions that have become so ingrained in our lives, we forget they even had to be invented. The telephone, the phonograph, bakelite. The first truly synthetic plastic, by the way. Then came the transistor, the foundation for our entire digital world. It just makes you wonder, what will be the next groundbreaking invention? The one that seems impossible now, but in 100 years, we won't be able to imagine life without it.
It's fascinating, isn't it? Imagine going back in time and trying to explain something like liquefying air to someone living a century ago.
Yeah.
They'd probably think you were pulling their leg. Yet that single invention revolutionized countless industries,
Okay.
from how we make steel to how we create chemicals.
It really puts into perspective how these seemingly small sparks of invention can ignite entire revolutions in how we live and interact with the world around us. But of course, it doesn't stop there. Once that initial spark is ignited, it often sets off a chain reaction of innovation, taking that original invention and making it even better, finding new uses, new applications.
And that's often where the real magic, and let's be honest, the profit light happens.
Right.
Innovation takes an invention from, oh, that's kind of neat, to, I can't live without this.
Think about it. Edison invents the phonograph, a landmark moment in capturing and replaying sound, a true invention. Then comes the wave of innovations, tape recorders, tapeables, the iconic Walkman, KB players, and now our smartphones. Each generation improving on the original, making it more user-friendly, more portable, more intertwined with our daily lives.
And sometimes these innovations unlock potential that no one, not even the original inventor, could have foreseen. Take optical fibers, initially developed for communication, transmitting information at the speed of light. Who knew they'd revolutionize medical imaging through endoscopes? Or allow us to peer into the heart of industrial processes, monitoring chemical reactions in real time.
Talk about seeing the light. And speaking of unexpected applications, the lecture also mentioned the electric arc furnace, invented by the brilliant Henry Moissan. Turns out, his invention wasn't just a one-hit wonder, it became a launch pad for further innovation.
Precisely. Moissan's electric arc furnace became this incredible platform. It revolutionized steel production, paved the way for the creation of aluminum, and opened up a whole new realm of possibilities with calcium carbide. It really showcases how one pivotal invention can become the cornerstone for a whole wave of innovation rippling through multiple industries.
And let's not forget about the impact of isolating elements, like chlorine. Now, chlorine gets a bad rap sometimes, but think about it. Isolating it as an element was a huge step, but it was the subsequent innovations that really made a splash. We've got safer drinking water thanks to water treatment advances, a whole slew of essential chlorinated compounds, and chlorine even became a key player in countless industrial processes. It really underscores how sometimes that initial discovery, that first invention, is just the tip of the iceberg. It's the continuous cycle of innovation that unlocks the true potential, leading to breakthroughs we might never have anticipated. But here's where things get really interesting. What if I told you some of the most innovative solutions are inspired not by staring at test tubes and equations, but by observing the natural world around us?
It's the beauty of biomimicry, taking cues from nature's design book to solve human challenges. It's humbling, really, when you realize that nature has often had a several million-year head start on research and development.
It's like nature has this endless library of solutions just waiting for us to crack the code. Remember those redwood trees we were talking about? The ones that practically touch the clouds? The lecture dove into how they managed to pull water hundreds of feet upwards, defying gravity to nourish those massive trunks.
It's a question that baffled even the great Pfeffer. the leading botanist of his time. He knew capillary action, the way water can climb up narrow spaces, couldn't fully explain how fluids could be drawn up hundreds of feet. It's a puzzle that still has engineers scratching their heads.
Right. Talk about a plumbing challenge. It's not like they've got tiny pumps hidden in those branches. So what's the secret? How does nature pull it off?
Well, the lecture pointed to a fascinating possibility: osmotic pressure. Picture this. The sun's beating down on the redwood's leaves. Water evaporates, leaving behind a slightly more concentrated solution in the leaves. It's like when you boil down a sauce, it gets thicker and more intense in flavor.
Okay,
Right.
that makes sense. The water's evaporating, but the stuff dissolved in the water is staying put, so it gets more concentrated.
Exactly. And that's where osmotic pressure comes in. Nature loves balance. The more concentrated solution in the leaves creates a kind of pull, drawing water up from the less concentrated solution in the roots and trunk
Yeah.
through a network of specialized cells called xylem.
So it's like nature's using the power of gradients, the difference in concentration, to drive this upward flow of water. It's incredible how something so seemingly simple can create such a powerful force.
It is, isn't it? And this principle isn't limited to giant trees. Osmotic pressure is fundamental to countless biological processes, from how our kidneys filter waste to how plants absorb water and nutrients from the soil.
It's amazing how nature takes these elegant, efficient principles and scales them up to orchestrate the functioning of entire ecosystems. Talk about inspiration for sustainable solutions. And speaking of elegant solutions, those perfectly defined stripes in your toothpaste, who knew there was so much science behind a minty fresh smile?
It's a perfect example of how even everyday products rely on a deep understanding of natural principles. Achieving those distinct stripes, preventing any color bleeding, requires a masterful understanding of rheology, the science of how materials flow and deform under stress.
It's like they've got to find the sweet spot where the toothpaste is fluid enough to easily squeeze out of the tube, but not so fluid that those perfectly engineered stripes turn into a murky mess.
Precisely. It's about striking that balance between viscosity, the resistance to flow, and yield stress, the force needed to make it flow. And it just highlights how essential it is to understand the fundamental properties of materials,
Huh.
especially when we're trying to mimic nature's precision.
It makes you think twice the next time you reach for that tube of toothpaste. And it's not just toothpaste.
Right.
This whole concept of controlled flow and deformation, we see it everywhere. From paints and coatings to cosmetics and even the food we eat.
Absolutely.
Yeah.
Rheology is all around us. And it's a fantastic example of how grasping a fundamental scientific principle can unlock a treasure trove of innovative possibilities. It makes you wonder, what other hidden scientific wonders are tucked away in our daily routines, just waiting to be discovered?
Speaking of hidden wonders, the lecture touched on something I found incredibly intriguing: how nature uses templates to create intricate structures. It's like nature's way of saying, why reinvent the wheel?
Ah, yes. Templating. Nature's been a master of this for millennia, using a pre-existing structure as a mold or a guide to create something new. It's remarkably efficient, and it's everywhere you look once you start to see it.
And it can be surprisingly delicious. The lecturer mentioned a specific type of rasgulla, that delightful Indian sweet. You know how they always have that perfectly formed cavity in the center? I always wondered how they achieved that.
It turns out the secret is ingenious in its simplicity. They place a sugar crystal at the heart of the cheese ball before cooking it in syrup. As it cooks, the sugar dissolves, leaving behind that signature void without compromising the rasgulla's delicate, spongy texture.
Talk about a sweet surprise. It's incredible how something so simple can create such a consistent, elegant result. And speaking of elegant structures, let's not forget about bones. They're not only incredibly strong, but also surprisingly lightweight, thanks to their hollow structure. So how does nature manage to create these incredibly strong yet lightweight structures? I'm guessing it involves some clever templating.
You got it. During bone formation, specialized cells create a sort of scaffold or template made of collagen, then calcium phosphate crystals. Yeah. The building blocks of bone are deposited onto this collagen framework.
So nature is essentially creating a mold,
Mm-hmm.
allowing the bone material to harden around it, and then voila, strong, lightweight, and beautifully hollow structure. It's brilliant.
It really is. And this principle of templating isn't confined to the natural world. We're now using it to create all sorts of amazing materials, from ultra lightweight yet incredibly strong ceramics to incredibly sophisticated filtration membranes.
Speaking of filtration membranes, the lecture mentioned an example that frankly blew my mind. using hair to create hollow fiber membranes. You're kidding.
It sounds crazy, but it's true. And when you think about it, it's actually quite ingenious. Hair is abundant, naturally strong, and incredibly fine. We're talking about diameter smaller than a human hair.
It's like nature's version of microscopic pipes.
Yeah.
So how do we go from a head of hair to a cutting-edge filtration membrane?
It involves a bit of chemical finesse. Researchers have figured out how to coat individual hair strands with a thin layer of polymer, essentially encasing them in a protective shell.
Yeah.
They cleverly dissolve away the hair, leaving behind these incredibly tiny, perfectly formed hollow tubes of polymer.
It's like alchemy. You start with hair, add a dash of scientific ingenuity, and poof, you've got these incredibly precise microscopic tubes. It's mind-boggling. What could we even use these tiny tubes for?
The potential is enormous. You can bundle thousands of these microscopic tubes together to create filtration membranes that are incredibly efficient in separating liquids and gases.
It's remarkable to think that something as seemingly mundane as hair could hold the key to addressing some of our most pressing technological challenges. It really speaks to the boundless potential of biomimicry. From those microscopic hair tubes, the lecture took us to something on a slightly larger scale gypsum, and those breathtaking sculptures created in salt pans. It's like we've been talking about how nature inspires innovation, but this example takes it to a whole new level.
Right, absolutely. It beautifully illustrates how innovation isn't always about conjuring up something entirely new, but recognizing the untapped potential in what already exists. Sometimes it's about shifting your perspective, looking at the familiar with fresh eyes.
Seeing opportunity where others just see, well, discarded gypsum. So tell me more. How do we go from salt pans to stunning works of art?
Well, you know how salt is often harvested from shallow open ponds called salt pans, right? As seawater evaporates under the sun, it leaves behind salt, of course. But it also deposits other minerals, including gypsum. For a long time, this gypsum was viewed as a byproduct, something to be tossed aside.
Wait, so they were literally just throwing away these beautiful crystals. I'm starting to sense a pattern here about nature rarely creates waste. Just resources we haven't figured out how to utilize yet.
Precisely. And that's where a little human ingenuity comes in. Someone, somewhere, had the brilliant idea to take this readily available gypsum, which naturally forms these intricate, often stunning crystals, and turn it into art.
Instead of seeing a waste product, they saw a blank canvas. I love that. So what kind of art are we talking about? Intricate crystal mobiles, sparkling gypsum mosaics.
Think bigger, bolder. They began by simply collecting these naturally formed gypsum crystals, which, as you said, come in a dazzling array of shapes and sizes. But then they took it a step further. This is where it gets really innovative.
Okay, you've piqued my curiosity. What did they do?
They crafted these large metal frameworks, sort of like stencils or molds, and submerged them in the salt pans. As the seawater evaporated and the gypsum crystallized, it formed around these frameworks, creating these enormous, incredibly intricate sculptures. It's like collaborating with nature, using its inherent processes as a force for artistic expression.
That's incredible. They essentially found a way to harness the power of evaporation and crystallization to create art. I bet those sculptures are breathtaking.
They are. And the best part, it's a completely sustainable art form, utilizing a readily available resource that was previously considered waste. Talk about a win-win for creativity and the environment.
It's a beautiful reminder that innovation often lies at the intersection of art, science, and a deep respect for the natural world.
It really is. And it circles back to something we've been touching on throughout this entire deep dive, the mindset of the innovator. So much of it is about perspective, curiosity, and a healthy dose of that what-if thinking.
Right. It's like, why do some people see a problem and think, challenge accepted,
Right.
while others just see, well, a problem?
Yeah.
What sets those innovative minds apart?
It's a question that has fascinated thinkers for centuries. And you know, the lecture presented a rather intriguing perspective, one I hadn't considered before. It suggested that a touch of naivety, in the best sense of the word, might actually be an asset when it comes to innovation.
Now, hold on a second. Before you dismiss this as utter nonsense, I'm not suggesting we throw out expertise and embrace blissful ignorance. But think about it. Sometimes not being burdened by the weight of conventional wisdom, but that we've always done it this way mentality, can be incredibly freeing.
Exactly. If you're too entrenched in what's considered possible, too constrained by the limitations others have set, you might miss those truly groundbreaking out-of-the-box solutions.
It's like that old adage, if I knew then what I know now. Sometimes that extra knowledge, those preconceived notions, can actually stifle creativity. The lecture quoted Dr. Michalker on this, and it really struck a chord with me. An innovator is one who does not know that it cannot be done.
Such a powerful statement. It speaks to the importance of approaching challenges with a sense of wonder and possibility, of not being limited by what we think we know.
It's about having the audacity to ask, what if? Even if everyone around you is saying, no way, because often those no way ideas, the ones that challenge the status quo, are the ones that lead to the most incredible breakthroughs.
And sometimes those breakthroughs involve revisiting what we thought we knew, looking at it through a new lens. Remember those peacock feathers we talked about earlier? How we marveled at their vibrant colors? We often assume those colors come from pigments, but as we learned, it's all about how light interacts with the feather's structure.
It's such an elegant example of how nature often arrives at these incredibly elegant solutions. Not by fighting against the laws of physics, but by working in harmony with them.
Precisely. And what's fascinating is that this concept of structural color, as it's called, was first observed centuries ago by none other than Sir Isaac Newton and Robert Hooke, scientific giants. And yet, we're still just scratching the surface of understanding its full potential.
It really makes you wonder what other natural phenomena we're only beginning to grasp, what other impossible properties and materials are out there waiting to be discovered.
It's an exciting thought, isn't it? And it highlights how important it is to approach innovation with a sense of humility, recognizing that nature often holds the answers if we're willing to ask the right questions.
And maybe, just maybe, a little bit of that innovator's naivety, that willingness to believe in the seemingly impossible, is what will ultimately lead us to the next great breakthroughs. So here we are at the end of our deep dive into innovations in chemical technologies. We've journeyed from the intricate chemistry of toothpaste stripes to the profound wisdom of not knowing, from microscopic hair tubes to the breathtaking artistry of gypsum sculptures.
We've explored how nature inspires not just what we create, but how we create it, reminding us that the most sustainable, elegant solutions are often found by working in harmony with, not against, nature's principles.
We've seen firsthand how a single invention can spark a wave of innovation, rippling through countless industries and aspects of our lives. And we've learned that sometimes a little bit of naivety, that audacity to ask what if, can be the spark that ignites truly groundbreaking discoveries.
So the next time you find yourself marveling at the intricate structure of a spider web glistening with dew, or the captivating patterns on a butterfly's wings, remember you're not just observing nature's beauty. You're witnessing the culmination of millions of years of evolution, a testament to nature's boundless ingenuity.
It's a blueprint for innovation, an invitation to delve deeper, to ask questions, and to never stop marveling at the world around us. Who knows what incredible discoveries await, just waiting for a curious mind to connect the dots. Until next time, keep those questions coming and those what-ifs flags flying high.